Welcome to Study Time, a televised home learning program produced by Rwanda Basic Education Board.
Hello viewers, welcome again. Here we are again with the senior sixes. Remember what we talked about last time. We're talking about populations of the different organisms, how to estimate them using the variety of methods in which we can tell how many organisms we do have of a given population. So we looked at fish, we looked at how they explode, we looked at examples of rabbits, we also looked at how we can estimate numbers for plants. A little bit different from the others. Now the question has always been, are we among the populations we need to consider? So today, our focus is going to be on us, ourselves, the human population. In which case we need to think about a lot of things. If our numbers go high or low, is our planet expanding? Do we have an effect on this planet we are occupying? Is there a possibility that we can have another planet that is able to support life? Should we explode this and it runs out of resources? So we are having one population dynamics, as you can check the word, population dynamics, the changes. Remember, these numbers are never static. So they keep oscillating and rising up, then going down, then rise, or continue to rise. So we need to ask ourselves a question. Is this rise a skyrocketing component that we shall ever continue to go up? And if we do, up to when? Is the time frame and the numbers having a very strong connection? So if we have the numbers, are we able to support them? So we think about all the resources. So changes in population will always kind of match and have to strike a balance between what we feed the population and how the numbers go up. So our objective, therefore, today is to be able to describe and state the nature of the implications if we have these numbers going up. The human population is our focus today. Remember that. A few things we need to look at, the basic terms that shall have to guide us, key important words. So we have one, crude bath. One would ask yourself, is this crude oil they are talking about, or it is another form of bath? Two, crude death rate. And then the third we shall come to in the next session, though we are not going to focus so much on it, is the demographic transition. When we talk of demographic transition, we are looking at the geography of humans, the numbers, sex, age, increment, and stuff like that. Then the other one, we have the doubling rate when we talk of exponent values. 2 to the power n, those who do math, what do we mean? If we have 10 organisms and then after a certain amount of time, this number doubles, are we looking at the doubling time? The other component is fertility. How fertile is our population? We are not talking about soils, but humans. Are humans fertile? When we say a family is fertile, as an example, what do we mean? Are we looking at the power to reproduce? Are we looking at the potential to give birth? So do we look at fertility in terms of only ability to produce, or ability to produce organisms, or humans able to give birth, their children grow, reach reproductive age, have a family, and produce as well? Then we shall consider that, okay, a couple is fertile because they are able to produce young, grow, mature, reach reproductive age, and be able to reproduce as well. That's what we look at in terms of fertility. But it's a very relative and broad term, so it has a lot of things connected to it. The last part is the rate of natural increase. Under natural conditions, under natural circumstances, when do we have numbers going up? Do they naturally rise? That if everything was to be left undisturbed, food is available, there is enough space and stuff like that, do we continue to rise steadily? And there are some situations where artificial circumstances, man-made conditions, kind of interfere with the way we have this natural increase in population. Which takes us to our next component. What exactly affects our numbers? So we need to think and say, Rwandan population, approximately 14 or slightly, because the last time we had these numbers, so much time has passed. So we need to think, did it stay static on the very day the announcement was passed on the radio and TV that today we are this number? Now the question is, at what time do we have the numbers made, calculated, and at what point do we have the numbers announced? Are we already late? Are these people carrying out census also considering mothers about to produce? That's something we need to think about. So, we have three major factors that do affect population size. So you have birth, you have death, and movement, migrations. In which case we are looking at how many births do we have versus the amount of people dying. So do we have death rates and birth rates being compared to know whether we are actually moving up or we are the same, or we keep, that curve up and down, up and down, up and down, so stable. Two, the changes in population in which we are looking at a combination of a variety of some of these aspects we've looked at. One, birth, when we add immigration. So we are kind of putting two things together. Become pregnant, give birth, add the number, but at the same time, some other people come into a given habitat, a given region, a given country, a given block on the continent. So we also need to think about, are we extracting people dying? What about those ones moving out? So at the end of the day, what exactly do we have? And then we look at rates more often used because we are looking at time frames. So you do not talk about populations minus time. What about crude birth rate? Remember, this is a summary. I'm just giving you an overview, a general picture. It doesn't stop you from continuing to read ahead and get the real grasp of these in detail. So we are looking at crude birth rate, crude. So we are looking at live births per 1,000 people in a year population. This is very interesting, that we tend to sit back in front of our TVs and radios and just keep waiting for those statistical figures that are released by the Bureau of Statistics. We have these figures. If the office dictates these figures and say, these are the numbers we have got, at the back of our mind, what do we think about them? If they say on average per family, we are having about 6 people, I need to start with my own family. How many do I have at home? Can I estimate the number of families Rwanda has, and then I'm able to also make my own calculation at the back of my mind and compare what I can figure out with what the presenter is giving us? Could there be some errors? So what does that mean when we talk of averages? Are there certain things that are kind of uneven? Could there be some kind of drawbacks in this process of counting, determining populations for countries, regions, and stuff like that? Are there people who sneak out of the country across borders that are not designated for transit? How do we cater for them? Illegal immigration, illegal migration, we tend to think about those numbers as well. So you have crude death rate, the deaths per 1,000 in a year population. So we are looking at a certain fixed number of people within them in a year, how many are born and how many do die. But what do these figures tell us? Do they scare us? What is the simplest representation of this information for a normal, ordinary person back home to consume and be able to make his or her own judgment? So we do have these numbers. The blocks provided are showing the average crude birth rate. So you can check the numbers of the yellow blocks. Interestingly, really big, as you can see. And the blue ones represent the average crude death rate. Not crude in a sense, according to grammar, that it's harsh death, no. But it's a representation in 1,000 of a year. Numbers in 1,000 in a year. Those are the crude values. Now, I want you to look at this and check where we can put our nation. What's the placement? So you have the world in general, and then you have the developed countries, and then you do also have all developing countries, and developing countries with or without China. Now, though this is slightly backdated, but at least it's up to around 2004. That was the time when the data was actually statistically collected and put together. Now the question is, why are they bringing in China as an exception? How much of the geography do you know? How much of the history do you know about China's population? Way back in your middle school, in your primary, China, most populated country. Were they considering the size of the land? Were they considering the number of families? What do we consider to finally say a country is densely populated? That the country outnumbers the rest of the countries in terms of certain numbers of populations. So with that, this comes to my mind and wants me to think about, based on my knowledge from geography, from general studies, SST for those in primary. Remember, this does not concern only X6s. Everyone at home can benefit. Do I place Rwanda in 11 to 10? Do I place Rwanda in 24 to 8? Do I place it at 29 and 9? Developed, developing, underdeveloped. There are certain words that have been kicked out. So think about that. You need to use this moment to link your geography, your general studies, global issues currently, merge them into this, and you are able to identify where your country is placed. Off we go to the next. Remember, the blue bars and the yellow bars. Crude death as yellow, and then we said the other color, which is now blue, would be the births. So let's check. When we look at this, if I can slightly take you back, deaths would be the blue, and the births would be the yellow. So remember, reverse that. I repeat, we are changing the colors according to the labels. So this is going to be for blue, and then the blue one here would be the death, so it is going to contradict with what I just wrote here. Check that very carefully. I'm slowing down for you to pick that. The yellow ones would be for births, and the blue ones would be deaths. Before we move, look at the bars very carefully. Check. We are taking Europe and comparing it with Africa. Think about it. Why the anomaly? Why a sharp difference? Let's look at Latin America. Let's consider Asia. The Asian Pacific, then we also have Oceania, then you have the United States, then you have North America, Canada, and all of that. What do these numbers tell us? And here is a very interesting question that you need to think about. Are we shooting upwards, never to come back again? Are we skyrocketing? Think about it. And if you're a family out there, you're also seated watching. Are you a contributing factor to this? What is the government strategy in terms of these numbers? Any family planning? Is it attached to certain benefits? Have 2 children, good. Free housing, free education. How do you support the education systems? How do you support government policies? Do you put it into practice, what you actually learn? Family planning in churches is talked about. Family planning everywhere is talked about. How do you space the children? If you don't, or if you continue to produce more and more, is it affecting your land at home? When it comes to giving inheritance, what are you thinking about before we come to that? So the other part is, where are we headed? Produce and produce and produce and produce and skyrocket. Do we have any backup plans? And the third, can the planet and its resources actually support these rising numbers? What if we run out of supplies? Start pressuring down the mills, small-sized saucepan. Because you're partitioning land, 4 sons, everyone gets part of the acre you actually inherited from your father. And then they're also going to pass on the small inheritance up to when you actually have the smallest size where only your house can be, so you do not have land to till. What about the children you're producing? Think about it. And if it does, if you actually know that you have land to pass on to your children, for how long can you sustain that? So we look at the numbers and still the baseline, the bottom line of it all, we are actually going up. Look at that power of numbers. 79 to the power, 79 times 10 to the power 6 people added every year on this planet that never increases in size. The matter, physics tells us, has never increased. It remains the same. Maybe with some bit of addition when we have rocks coming up. So, to wrap this up, where does this take us? Do we know the picture? What about, like in 200 years from now, if this planet is to stay and support us? Do we have all it takes? Which takes us to that. Look at it. The time is yours. Pay attention to the slide very, very, very carefully. Where are we now? Is this what we are anticipating to see in 2,500 years from now? We are just in 2020. We are just in the second millennium. What about halfway into the third? What about halfway within this one we are in? The second point I want you to look at is, what does the trend tell us? So in terms of the trend, we are looking at, we move from here, so we go. This is our trend, a dip, a trough. And then we rise again. Take note of the black word written there, Black Death Plague. How much is your history? Do you remember these world historic events? Or you're even going to forget the COVID-19 that just happened the other day? We need to have data. We need to have statistics if we are to plan ahead. So, you have the plague happening here. Numbers sharply drop. Now, the question as part of your homework should be, how much in terms of population was lost in Europe during that time? And then we have a slight rise, and then we continue 1830. Choop! We rise. And there we go. Is this what we are looking at as our exponent? From here to here, in terms of the boxes, if I do the math, 1, 2, 3, 4, 5 boxes, between 1,500 AD to 2,000 after death of the Christ, then it means that I'm going to have these boxes, count them, look at that range, divide to know how much each box represents. That's math. Graph. A skill you need. Then I will check. In one box alone, how much have I gone up in terms of billions? Jesus Christ. From 1 to 4, in only one of these, which has a small representation of maybe 2, 5, something like that, by simple math. And then off we go, and where are we? 2013, the other day, and 2028, we are now counting down. Only 7 years to come. 08, 06, boom, there we go. Look at the numbers. Now the question is, around here, for those who will be alive, that is an expected number, you shall be. Some might start thinking, I don't want to be alive at that time because I do not want to compete for even a drop of water. Which takes us to exponents. World populations over centuries. What is going to happen? And here we have. I want you to look at this graph and look at the colors, and we also have the percentages for each of the colors. Some regions, the data is not catered for, so it's colored plain white. I want you to make a comment on these variables in terms of percentage population. Look at the region of Africa, the color, and also the number. Does it outnumber the others? Is it ranking highest? 3+ as a percentage. That's big. What about others that are less than 1? What are they doing? Any family plannings? So, like we talked about, why do our numbers dwindle? And why are certain countries adopting certain ways or strategies in which the numbers actually keep balanced? Not so much increase and not so much death. You can look at that, identify the cause of death, COVID, control it. Simple. Stay home like you are now. Improved nutrition. Are we having certain varieties of foods able to grow faster? We have enough food and stuff like that. What about discovering antibiotics that are able to treat some of these diseases? All that embedded in there. What about childbearing? What is the potential of our mothers to bear good, healthy, upgrowing children? And we now look at once we have skyrocketed. Remember, we have this, skyrocketing. When we are here, and finally we reach here, and finally we go here, and then here. Implications? Are we safe? So we go again to the same slide and check this out. We might have to start competing. Can we continue to use and reuse what we have so that it stays for the next generation? Are we straining our environment? What was the initial size of Akagera National Park? And increased food production? What about that? And we wrap this up here on the chart. I want everyone to focus on the chart, on the board, so we are moving here. So, you have an explosion, skyrocket, so much that we cannot contain. And we have the branches. Get out, you are going to over-cultivate, effects erosion, fertility loss, so less productivity of the land. Overfishing, we talked about that last time. How much are we remaining with in Lake Kivu? Do we still have some bazaars and all that stuff? When it comes to poaching, the question is, are we doing it illegally? What about other activities that tend to reduce this as the impact of this explosion? You don't have enough meat, you go to the park and hunt an animal. When we have to move to cities, then there is a very high possibility that disease spread, slums, high population, then we now start having antibiotic-resistant strains, and here we go. We would still have new land into cultivation. We have to deforestate, draining wetlands, and immigration. And it's a complex web, as you can see, how the whole thing is interconnected. All these you see here are a result of a population explosion. And once all these have happened upcountry, how do we pressure our developed countries? Are there times when they are hating to give us their visas? Are we a burden to them? Cause a burden home, then shift it to the other end. It doesn't work that way. It does not. So as we wrap this up, that's what you need to think about. Is what I'm doing able to affect the other country? If they are controlling their own problems and have solutions, what about us? That's what I want you to look at. And thank you for this today. Keep looking at that, and off we go now. We are done. Thank you.